Okay, business algebra, let's talk polynomial functions. We probably know what a polynomial is, but the parent function for any polynomial is x to the n, where n is the largest power of that polynomial that you see. The number of zeros of a polynomial is at most that n. So for example, x squared, the quadratics have at most 2 zeros. Complex zeros come in pairs, which means every odd degree function has at least 1 0, because of course pairs can't take care of all the odds. And the behavior at zeros, how a graph behaves at 0 depends on the multiplicity. The multiplicities can be separated in 3 categories. Multiplicity 1, the evens, and odds greater than 1. So let's take the function x plus 2 times x plus 1 squared times x minus 1 cubed and describe what happens. So at the root x plus 2, it's to the first power, which means it just crosses normally. So when you think of the line x plus 2, generally, without the rest of it, it's a line. It just has a constant slope. It would cross its 0 normally. What about x plus 1 squared? It's quadratic. What do quadratics do at their roots if there's something squared? That's usually their vertex, which means it levels off, but usually term doesn't cross. I like to tell people, imagine you're trying to make a decision to cross the river when you're already in the river. And every time you make the choice, you choose something different. So the first choice is you're going to cross the river, but then the second choice is you turn back and stay on the same side. So every time you make an even number of choices, you end up on the same side, but you go all the way there before turning around. Now x minus 1 cubed, same thing, same river idea, but because you're making an odd number of choices, you in the end decide to cross the river. So I say it will level off, which means it becomes horizontal temporarily, but it ultimately crosses to other side of axis. Now, some not so mathematical definitions here that go along with this. And all other odds and evens, by the way, behave the same way as the last two. Turning points. If it's a degree n polynomial, it has one less turning point than the number of roots, because in order to get from 1, 0 to the next, you have to be able to turn around. And then end behavior is more important. You can kind of think of the end behavior as aligned somewhat with the range in some way. It's really for at least a regular polynomial. When we get to rationals, that'd be something slightly different. But the end behavior is what happens to the graph as you reach very large positive and negative values for x, which is determined entirely by the degree of the function and the a value, the coefficient, next to the largest function. So for functions, when x gets very large or very small, which is a large negative number, raising it to a power gives it much more power than any other part of the function. If we think about x cubed and x squared at, say, 1,000,000, 1,000,000 squared is 1,000,000,000, which is a 1 with 12 zeros. 1,000,000 cubed is a 1 with 18 zeros. It's literally 1,000,000 times bigger than the trillion, which means it is a lot more powerful and has a lot more sway on what happens on the sides. So you get to ignore everything else except the largest degree, largest exponent term, and the coefficient that's in front of it. So let's talk about what the possibilities are here. Okay, so how the graph looks at the end is determined by the leading coefficient and whether the degree is even or odd. So we have options here. Either as a is positive or a is negative, and the degree could be even or odd. So we're just going to look at the very most basic version of these. Starting with odd and positive. So the most basic function that has an odd and positive that's greater than 1, just to be safe, is x cubed. And what does x cubed look like as a graph? It levels off in the middle, of course, but it goes up on the positive side and down on the negative side. So what's happening? We say as x goes to negative infinity. As x goes to negative infinity means as I go further and further left, what is happening to my function? F of x is going, it looks like further and further down. So that means f of x is also going to negative infinity, which represents as we go down. Now, on the right side, as x goes to positive infinity, it looks like the function is going up. F of x is going to positive infinity. So this is how we state end behavior. It's really asking as x is going to the left, what's happening to my y values? It looks like they're going down. As x goes to the right, it'll continue to go to the right. Because we see no more zeros, there's no way that it can really turn around and do anything else. Otherwise, we would see it coming down at some point. So f of x goes the numbers become very large. It goes up on the graph. Now, what happens when a is negative? For example, if this was negative x cubed, it just takes your graph and it flips everything, which means it's now going up on the left and down on the right. How does that affect our end behavior? It says x goes to negative infinity, which is still the left. Now on the left, we are going, looks like up, so f of x is going to positive infinity. Now as x is going to the right, so as x is going to the positive infinity, now f of x is going to negative infinity. So what did the negative do here? Remember, a negative in front of the whole function switches the y values. Now it's the f of x that is the y value in this case, and it flipped the sign of both of our f of x's, which is exactly what a negative in front normally does to a function. And what about if the exponent is even? The basic function for even powers is f of x equals x squared. We know this to be the parabola. Anything squared is non-negative, which means what's happening on the left? As x goes to negative infinity, f of x is going to positive infinity because it's going up on both sides. So as x is going to positive infinity, the right side, f of x is still also going to positive infinity. So this is one thing that differs between odds and evens. If your largest degree is odd, they go to opposite directions. However, if your largest degree is even, they're going to go to the same direction on either side. Because again, squaring negatives and positives gives you positives. But cubing negatives and positives will give you either a negative or a positive depending on what you started with. Lastly, if a is negative, so the leading coefficient for x squared is negative, negative x squared. It takes your parabola and flips it, so it's now going downward. What does that mean? As x goes to negative infinity on the left side, f of x is going to negative infinity, and as x is going to positive infinity, f of x is going to positive infinity. Now this, again, the negative in front just f of x is going to negative infinity. It just flips the y values again, so we see the difference between these two is the f of x's change sign. Again, the fact that they go to the same side is represented by the f of x's going to the same place on both of these, and we will continue and use some of these applications in the next video.